we were here, okay? We graphed the constant f of x, which is the same as y equals to 2. We graphed the line. We started looking for the vertex of your quadratic function. We found h, and we plugged h into the original equation to find your k. So currently, we have h and k. That will allow us to transform. Okay? But before we transform, let's talk about the parent equation of this. What is the parent equation? What do you guys remember? Y equals what? Yeah. If we quickly can get the table for this, I'm going to do it horizontally. We go -2, -1, 0, 1, and 2. What are the 5 outputs? 4, 1, 0, 1, 4. Okay, so those are the inputs and output of the quadratic equation. But we are not graphing the parents. We're graphing something that has an h value and a k value. By the way, if you have an a value of 1, does that reflect vertical stretch, vertical compression at all? No. So we only have an h value of a -1 and a k value of -4. If h is negative, what direction are we going? Naturally, h is negative, you go where? To the left, okay? So that means I'm going to take my original x and I'm going to subtract 1. If k is -4, what direction are we going? Yeah, down. So k minus 4. You can even go and just plot the vertex right away. -1, 2, 4. Can you guys see the vertex is now moved left and down? All right. Remember, the parent function has a vertex at 0, 0. Okay, so take all your x's, the original parents, subtract them. Take all the y's, subtract 4, and then give me the 5 inputs and output. We'll plot those. Just a reminder, class, make sure you sign up for your retake today. Today's the last day to sign up for your retake 2A. Your retakes are tomorrow and Thursday. On Canvas, under it says Unit 2A retake. Under assignments, yeah. Come back at tutorial now. Maybe I'll show you, okay? Yeah. We'll locate it for you. So Tyler, give me the 5 new outputs when you're ready.
0, -3, -4, -3.
0 is the first output, right? And then what's the next one? -3, -4, Good, okay. Anyone disagree? How about inputs? What are the new inputs? -3, -2, -1. Perfect. All right, plot those. So -3 is 0. -2 is now -3. Okay, there we have it. That's one way, by the way, to graph. You don't have to graph it that way. If it doesn't ask, you can graph it however you like. Okay. So now that we have the first 3 graphs, we will now answer all the information on the next page. So we are going to flip back and forth a little bit on your notes. My notes, I'm able to just go up and down. Okay, we're going to compare these 3. What is the degree of the constant function? What is the degree of the constant function? Huh? Is it 1? Then what is the degree of the linear? So they can't be the same. Now let me tell you guys why this constant function would have a degree of 0. This is the same thing as saying 2x to the 0 power, because anything to the 0 power is always what? It's always 1, okay? Anything to the 0 power, it's always 1. So 2 times 1 becomes 2. Okay, that's why this has a degree of 0. So constant functions will always have a degree of 0. linear functions will always have a degree of what? 1. Now, we're now on to third equation. What is the degree of the quadratic function? 2, exactly. Now look at the x-intercept for the constant. Okay, you can even look at my projector. For this particular case, does it intersect the x-axis at all? No. So for this one, we say none. Okay. How many x-intercept do we have for the linear, for this particular linear? 1. Now, how many x-intercept do we have for the quadratic? 2. Okay. So usually these are related. If the degree is 2, you will have at most, again, at most 2 x-intercepts. If the degree is 1, you will have at most how many x-intercepts? 1. You may not have any, but that's at most. I mean, the most you can have is the number of the degree. You can have less, but that's the most you're going to have. Okay. Number of turning points. Anybody remember what from yesterday? What was the definition of turning point?
When the direction of the y-axis reverses.
Yeah, right? You start to go up and then it goes down. That's turning point, just like us, right? We turn as we are going left and right, but this goes up and down or down and up. So for the constant, does it turn? No. So number of turning points, 0. How about the line? No, it doesn't turn either. Okay, so 0 turning points. How about the quadratic function? 1, you're right. Turning points is kind of similar to your minimum and maximum. For this to turn, it has to go down and then go back up, or vice versa. So that's why there's 1. So let's connect those really quickly. If you have 2 degrees, what's the most turning point you're going to have? Exactly. The most, again, most means the highest. Technically, for this one, I don't have to have any, right? Okay. Now, this is the language that we want to look at. Can you guys see there's an x and there's an arrow and then negative infinity? And then a y arrow and then blank space? Okay. This is the end behavior right here. And yesterday we defined the definition for end behavior, and we talked about for the constant function, okay, as x approaches, okay, it says verbal down there, so we're going to spell that out. As x approaches negative infinity, y approaches, and then we're going to fill that out. Okay, for your constant. Negative infinity is over here, right? So as x is going left, what is the y value? It's staying at 2 because it's constant. Okay, constant means y would never ever change. So y approaches 2. Okay, that's verbal for us. Any question on that so far? Okay, so then we'll take the line. As x, I'm going to use a different color. So as x approaches what? Negative infinity. Y approaches. Okay, so the line is slightly different. As x approaches the left side, which is negative infinity, what's the behavior of the y? Does it go upward or downward? Downward to where? Where does it stop? Never, right? So that's why we're going to get y approaches negative infinity. Okay? So for that one, as you can see, the y goes downward as we're going to the left. Now, let's look at your third function to the right. Verbally, we're going to say as. And the reason we're spelling verbally right now because we have never really studied these. As x approaches negative infinity, y approaches. Okay. So again, negative x is going to be to the left. So as x is going to the left, what's the behavior of y? It's going up. So that's why we call these end behavior. End behavior is when you go either all the way to the right or all the way to the left. So can you guys see that they're different every time or could be different every time? Okay. Okay, so those are algebraic notation. Now, some of you are going to go to calculus. Now, in calculus, we use this limit notation, okay? And let me write this out for you. So for this one, limit notations like this. They use the word limit, okay? Limit. And then we're going to write x, arrow, negative infinity, just like that, okay? So the limit as x approaches negative infinity. Now for our function, the name of this function is f of x. Can you guys see that right there? So these are all the names. That's why these are usually really important because that's what we use following this. So the limit, okay. So this is the limit of f of x. In this case, this is talking about the constant function as x approaches negative infinity equals, for the linear, what does it equal? 2, yep. These right here, class, they are talking about the same exact thing. So this is all 2. So all of these right here are answering the same question, just different way of talking about it. Okay? So these are verbal of that, and this is calculus notation of that. Okay. So in the middle one, we know that this answer right here, this blank space, was a negative infinity. So the limit notation would be limit. On the bottom of the word limit, we write x, arrow, negative infinity of f of x, and this f of x is linear. And we would write equals to, what is it equal to? Negative infinity, yep. So again, these right here are answering the same question. And then the one to the right, we knew the answer was what? What was the answer of the one to the right? Infinity, yep. So in calculus, we write the limit as x approaches negative infinity of the name of the function. In this case, we were using f of x. It could be g of x, it could be h of x, it could be anything that the original was created, and equal to, what would that equal to? Infinity. So all of those are answering the same concept. Okay. Now the verbal on the bottom. Okay. Can you guys see, how would you read this before I write it out? What would this say? As x approaches infinity. I'm looking for what y is approaching. Okay. So for the constant, what's y approaching? 2. We knew that was 2. So as x approaches infinity, y approaches 2. Okay. And limit notation, limit as x approaches infinity of f of x equals 2. We'll write them all at the same time. Now on an exam, I could put any one of those language. I could put this language, I could put the verbal, and I could put the calculus. You need to be able to know what the right choice is, okay? In the middle, which is your linear, let me move it back up really quickly. As x approaches positive infinity, which is now we're moving to the right, what's happening to y? Y is going up. Does it stop? No, because the arrow means it goes up forever. So this answer would be a positive infinity. Okay. So verbally, we say as x approaches positive infinity, y approaches also positive infinity. Limit notation, we write limit as x, arrow, infinity. The name of the function, we were using f of x equals infinity. The one on the right, as you know, it was a quadratic equation, and it was opening up. So what was the answer as y approaches? As x approaches the right, which is positive infinity, what was y approaching? Infinity. You're right. Okay. So as x approaches infinity, y approaches infinity as well. So limit notation, the limit as x approaches infinity of f of x equals infinity. So that's the end behavior. So end behavior is talking about the extreme, all the way to the right or all the way to the left. Okay? We're going to try to answer the same thing for the bottom three functions, the cubic, the quartic, and the quintic. Quartic, guys, how many degrees is that? Take a wild guess. 4. Okay. We'll graph them out first, and then we will try to answer all of the same concept. All right. Go ahead and take out your calculator for me if you have one, or graphing one. Okay, if you don't have one, can you go borrow one? I'm going to teach you how to use a graphing calculator. Or if you have your Chromebook, you can use decimals. Either one I will accept. If you have a Chromebook, use a Chromebook. Okay. I have another class set over here, so use your Chromebook. It's just as easy.
Rating system.
But if you wish to borrow another graphing calculator, all right. If you use your Chromebook, go to decimals. Totally fine. Okay. And go ahead and graph out your cubic function. So cubic, quartic, and quintic for this class. Next year, you'll learn how to graph those by hand. But in this class this year, we'll do it on your calculator. But you are expected to graph by hand up to quadratic. Okay. So your calculator, go ahead and power it up. Okay. If you have a calculator, decimal students, you are free to graph those. Okay. On your own. So go ahead and power it up. Can you do me a favor, hit mode, make sure you are in, because my calculus class uses these as well. Can you hit mode, find the word mode, make sure you're under function. Can you see the word function? If you borrow my class set, you're most likely will be under something else. If you have a Casio, I won't be able to help you, so make sure you know how to graph. And then hit enter, and then quit. Second mode is the quit button. Decimal, you can start graphing on your own. Casio, I won't be able to help you very much, so make sure you know how to do it. So we have no function on the graphing calculator? Okay, hit y equals. Can you find that button? Y equals. Can you find the y equal button? If you find it, can you share it with your friends? If you found the y equals, can you share that with your friends? Just go graph a regular TI. Guys, if you have a Casio and you don't know how to use it, can you just go graph a TI on my desk? Can you find the Y button? Okay. Okay, perfect. Now I would like for you to find under the word mode that we just changed. Guys, under the word mode, can you see it says X, comma, T, comma, theta, comma, N? Okay, that's your variable X, okay? So for this particular graph, I would like for you to enter in X. So that is the button for X. Go ahead and press it. X is gonna appear. X, can you see X appears? Anyone else struggling? Can you ask your neighbors right now? Are you struggling? Ask your neighbor right now how to do all of that, Kendon, since you just got yours. Today is a day of like, hey, let's work together of how to use new technology. Anyone else? Try to enter in the cubic. This is your variable. Great. Everybody has an X, right? Okay. No, you don't have an X? Let me see. X is this button. You all got it? Okay, this is that. Okay, now we need to raise it to the third power, or fourth, or fifth, okay? Are you guys ready? Can you find the carrot and under the word clear? It says there's a little hat. Okay. Find the hat for me. Under the word clear. Where's the clear button? Work together. Stay focused. Under the word clear. Hit the hat. Okay. I want us to stay on the same page, guys. Are we okay so far with clear? Good. You got x squared. Beautiful. Put 3 in there because you want it to be third power. Everybody can get, there you go. Okay, try it again. X, caret. Perfect. Third power. Great. So now you should have x third power, or if you have an older calculator, right? X, caret. Third power. Okay, now I would like for you to enter the rest. I would like for you to enter in. You already have x to the third, yes or no? I want you to do minus 5x plus 2. Okay, enter that in right now. And I want you to take your calculator. Once you have it entered, I want you to take your calculator and switch it to the person. Make sure the entire function, guys, not partially, okay? Minus 5x and plus 2. All right, plus 2. I want you to show your calculator to the person to the right of you. So make sure that person needs to check the equation, guys. You too, show each other. Make sure you guys have the right equation. Look, does your friend have the right equation? Perfect. I would like for you to go to, ready? I want you to go to Zoom. Hit the button, Zoom. Where is Zoom at? Right, there it is. Right in the middle of your screen. I want you to go and where it says Zoom Standard. What number is Zoom Standard? Good, go there. What do you see? Okay. Is it graphing for you? If it doesn't, please let me know. The decimal student, you should already have it going, right? Yeah, it's even easier. All right, Zoom Standard.
Yeah.
Yeah. Okay. That's how we use a calculator to help us sketch our graph. Okay. Now, I want you to hit the left and right arrow. Can you hit the left and right arrow? Find the arrow. Can you see that there's a cursor that moves? Okay. I want you to move it to the maximum. I want you to take your calculator. Move your cursor to the maximum so we have an approximation of where that maximum is because we need to plot this. Next year, or if we have time later this year, I'll teach you how to find it exactly. But right now, we're just going to move that for an approximation. So what is that approximation of the max? What's the x and what's the y? Read the x and y for me. Negative 1 point. Negative, let's round it to the nearest tenth. Negative 1.2? Okay. What's the y value? 6.3. Okay, let's plot that. Okay. How fun is that? Yeah. All right, so the max is negative 1.2. I'm going to approximate that. 2, 4, 6, and some change. So this dot class, negative 1.2 and positive 6.3. Okay, that's my max. Let's find the minimum. Use your cursor again. Find that bottom point and round to the nearest 10. And let me know when you have an approximation, just to confirm with me.
1.2.
1 point. When I have it about 1.3 now.
Yeah,
Like
I have
1.28.
I have about 1.32
Okay.
the last one as well.
Yeah, oh, you had 1.3 as well in the last one?
Yeah.
Oh, okay. Yeah, so about 1.2, 1.3?
Yeah.
Okay. So remember, this is approximation, so it's not going to be exact. So 1.3 and about what? Negative 2.2. Negative 2.2? Okay. So in between negative 2.2, negative 2.3, negative 2.4, those are fine. This is, when we have time, I will teach you how to find these exact locations. Negative 2, so I'm going to plot it right there. So 1.2 or 3, I'll take either one. And then negative 2 did you guys say negative 2.3? Yeah? Or 2? 2, okay, yeah. Either way. All right, perfect. So at 2 locations. Now I want you to move the cursor. How many x-intercepts do you see? 3, good. I want you to find all of them. Let's go from left to right. So we have a look. Okay. Let's find all the x-intercepts. What's the furthest left x-intercept? About where? Remember, the y has to be 0, okay? So look at the y screen. Make sure it equals 0. Is the y screen saying 0 on your calculator? Yeah. So my y screen says 0, and my x is about negative 2.3? Yeah. Perfect. So that's your first x-intercept. And again, once we have time, and when we have time, I'll teach you how to find these exactly. So negative 2.3, so negative 2.3 comma 0. What's your next x-intercept? 0.45. Okay, so about between 0.45 and 0.5? Okay, so about right there. I'm going to label this 0.5, if that's okay with you. I'll take 0.45, no big deal. And then where's the last one? It looks about 2, right? 2.05. Yeah, that's right, 2.05. So about 2 I'll take, okay? These are all approximation, so 2 comma 0. Okay, and then guess what? All we got to do now is follow the curve and sketch it out. You will learn how to graph these by hand in the future, just not this year in this class. Who's really sad about that? Okay, let's do the same thing for the quartic. Can you go back to y equals, and I want you to hit clear. Go back to, and then enter in the quartic equation to practice. And I want you to do the same thing, okay? If you have decimal, feel free to use decimal. So go back to y equals, hit clear. Clear to clear out the previous information. And do it together with your team. The more you practice, the better you'll get. And then I want you to sketch it out just like what we did for the cubic. Once you're done with the quartic, can you move on to quintic? Okay, I want you to graph all 3 functions using your calculator. Error. Okay, go back to the graph. You're not graphing x, right? We want x to the 4. So okay, go up to plot, you know, hit enter. Entering between the 2 and then now go zoom and zoom. That's coming. All right, I want you to find all the mins and max, plot it. I want you to find all the intercepts, plot it, and then sketch it out. Tonight's homework, guys, you may not use a calculator, okay? You cannot use it, you have to graph it as we have been graphing. Because we need to practice for your quiz. So you can use a calculator only for 4th degree, 5th degree, tonight's homework again, do it old school. Once you guys are done with your fourth power, can you go into fifth power? Don't forget to plot out your min and max and the x and the sub for you to have a good sketch.
You shouldn't have a multiplication. See, you have a multiplication right there. You should have
That's like the best way to describe
Yeah, what x do you use?
Wait, hold on, just a second. I am.
That's a negative.
Yeah.
Okay, so that's probably one. Okay.
Oh,
Anyone else not getting what your friends are getting?
no.
I want to make sure.
Plus 4.
Okay, yeah. Yeah, go ahead and figure that out for me.
Standard.
Show me how you enter it so I can help you. What did you do? So let's do this again. Go ahead.
Whoa. Yeah. Have you ever seen like beneficiaries fake cartoon showing up on the TV? It's just like so wrong. Like you don't even get anything, you just get one line. It's just
Beautiful. What you did was you cannot use this right here. This is a negative sign. This is a minus, so there's a difference. If this was a negative x before, that would be the front, and then everything would be minus. So that has to be this. This is what you press as a minus, and you're not supposed to press that, okay? Everything in there except the lecture. 2 B's, yeah, all the 2 B's. Not. Yep. You're welcome. Okay, if you guys are done with fourth power, can you move on to the fifth? I'm gonna see if I can copy somebody's fourth power. Who has all their points labeled? So I can come on. Okay, I'm gonna come to Juliet and see. I'm gonna copy your points and then sketch it out. So the first x in a set is -1, 0. The next x in a set was 1.2. Is that what it was?
This one negative.
Oh, 0.5?
Oh, for this one.
X in a set, 0.5 comma 0?
Yeah.
0.5. Okay, so -1 comma 0. 0.5 comma 0. And then the third x in a set, 2 comma 0?
Mm-hmm.
Okay, so 2 comma 0. Okay, and then I'm going to go and you have a minimum right here. That was a -0.4 comma -4.6.
-0.4 and then 4.6.
Okay.
Negative.
So -0.424 right there. So -0.4 and -4.6. Okay. And then this maximum was 0, -4.
No, that one was 0.6, and then.
Oh, that's right here.
That's the.
That's that right here?
Intercept
Oh, that's minus that. And then this one,
is the 0.6.
0.6 comma -3.4.
Mm-hmm.
Okay. 0.6, 1, 2, 3. Okay. So 0.6 comma -3.4. Then you have another minimum point right here as a 2 comma -8.
Yeah.
Beautiful. Thank you. So that 2 comma -8. All right. So it looks like
Bro, it's an ad.
I'm using Juliet's here. Does it look what you guys should have? Something like that?
Yeah.
Yeah, somewhat.
It doesn't go back up all the way.
It doesn't go back up all the way?
No.
No.
It kind of goes up a little and then drops.
Oh, that's an X intercept, yeah. Okay. So it looks like, does it go like that? Like that? So that's just an extra point that I had for no reason. Like that, right?
Yeah.
Okay. And then the quintuple, how many X-intercept do you guys have?
I had 1, 2, 3, 4, 5.
5? Okay. Can someone give me those points? I'm just gonna plot them.
Not negative 1.9.
Negative 1.9 is one of them. Okay, so.
Around there.
Okay.
Just like, and then somewhere around negative 0.7, 0.6.
Negative, oh, so it's like super tiny.
Yeah.
Right, so you know what I'm gonna do? I'm gonna rescale this. How about negative 1, negative 2, negative 3, like that. So that way I have more space, okay? All right, the first one was negative 1.9.
Something really close to negative 2.
Okay, and the next?
Next one's really close to negative 1.
Okay.
And then 0, 0.
0, 0.
And then somewhere in the middle of 1, 0 and 1. And then exactly.
Closer to what? 0 and 1? Closer to 1?
Closer to 1.
Okay.
And then exactly on, like basically exactly on 2.
Okay. And then do we start in the bottom or the top?
We started down here.
Down here. Now, how high do we go up on the first X-intercept? Anyone else has the first maximum point? Where was the first approximation of the maximum point? Because now I got, looks like I have the end behavior. Okay. Does it look like it starts going down and then goes back up according to what Audrey has over here? Okay, so I'm gonna copy Audrey's graph. What that height right there, Audrey? What is that about?
Negative 1.7 and 3.5.
Okay, so negative 1.7 and 3, 1, 1, 2, 3 right there. Okay, so it goes like that. And then this is about where? About negative half?
Negative 0.6 and negative 1.2.
Negative 1.2, thank you. Negative 1.2. Okay, so it looks like I can go bam, bam. Okay. And then now I'm curving up to that max, and that max is,
Oh, wait, are we doing?
I'm sorry, round 1. This is back to 0.
Yeah. Oh, wait, no, that was 1.63 and 1.2.
Okay.
It's about 1.7 and negative 3.2.
Okay, so there's a, so like that,
Yeah.
and then this a little bit, but down here?
Yeah.
So then, okay. Does this look about right? What I'm copying between Logan and Audrey's? Not as smooth as your calculator, obviously, so I'm gonna round that out and make my dots a lot bigger. Does that look about okay? About. Okay. All right, this is where we'll stop being for today. Tomorrow we'll compare those 3 graphs.